very nice you all came here tonight. I think the attraction is probably the cocktails. It's very nice that so many people here are so interested in cocktails that they're also willing to swallow some science along the way. That's why I also think it's a very good initiative. In fact, the last public lecture I gave was at the Kulturnat at the Niels Obers Institute. And I really don't say, I mean, with all respect for people over 60, but men over 60, but that audience was filled with entirely that population group. So it's very nice, different genders, different ages, and so I hope I can tell you something exciting about the quest for a fundamental theory of nature. Maybe I should say a little bit about myself. So I work as a theoretical physicist in the theoretical particle physics and cosmology, a lot of blah 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 names, group at the Niels Bohr Institute. That's a great institute, and it's of course, and I don't say this just to pleasure the Danes here, but it's of course a great privilege to work at such a renowned institute founded by the great Niels Bohr. In fact, well, you might think I'm Danish, but I'm not Danish, I'm Dutch. And you know, you can permute the numbers a little bit, and I don't want to see anything into it, but believe me or not, I have had to explain sometimes, like, how can it be that you work in an institute named after yourself? But anyway, so I saw that the Danish translation for the title of this talk had the word jakt in it, and that's and I was worried, is that the right translation for quest? But in a sense, it's even more correct than quest. Jakt means hunt, and if you consider that truly in our field there are some very, very competitive but sportive people that all want to shoot, want to be the first ones that shoot the animal, then the word jakt is really quite appropriate. So what does it mean to find a fundamental theory of nature, or maybe in other words, if this would work, yeah. Another way to start thinking what's a fundamental theory is to think what are fundamental questions you could ask, and the answers to those might lead you to the fundamental theory of nature. So here I've listed three fundamental questions. One is, what are the basic constituents of nature, or what we are built of, and what are the laws that govern their interactions? Like we also know it with people, you put them together, something happens, an interaction happens, and likewise it's with the smallest or particles in nature. You want to understand why they interact the way they do. Another sort of fundamental big question is how did our universe start, and what is its fate? I don't know, but I would guess that most people who breathe sometimes have this thought, maybe not every night, but maybe you wonder sometimes what was before that and what's beyond our universe. Another one is that's a little bit more technical, and I will hope to partly explain the words in this question. So I don't expect you to understand this question, but what is the quantum structure of space-time? So actually part of the lecture will be, what are the words behind it, and what is the proposal for an answer to this question. Now, in these questions, there are obviously two, in physics we have two tools to start addressing these questions. And one is experiments, so doing things, observing, and then seeing some patterns and making laws, and then applying it to other systems and seeing, hey, that works, or hey, that doesn't work. So that's the more step-by-step approach by observing. And the other is theory, and so that takes more a higher point of view, where you take some generally accepted principles or concepts, and you start to work from there, or with some hypothesis, and then you come to some conclusion, and then you maybe go and test it, and you see if it's right or not. If it's right, you're very happy, and you might even get a Nobel Prize. If you're wrong, you're, well, not unhappy, because you still had fun doing it, but you start trying again. And that's sort of life for most of us, just to be honest. And of course there's a big interplay between these two. Like theorists could be motivated by new experiments with strange results that they have to explain, and likewise experimentalists could be inspired by theorists because they have predicted some strange result. Well, those were very fundamental questions, but there are of course other important questions. And one is, can one mix science with cocktails? And like we all do, and there's not only physicists, everybody does this, our children, anybody we know, your mother. If you have a question, you just consult Google. So what happens if you Google the two words science and cocktails? And it's actually remarkable that it's all about the science of cocktails. There's nothing about, you know, cocktails while doing science or science while drinking a cocktail. It's all the science of cocktails. So that's kind of telling. And here you see a picture. There's certainly cocktails involved, but you wonder how much science, even though they might give the impression. But if you still want to draw some parallels, then making a cocktail is a little bit like constructing a theory, and drinking the cocktail is sort of testing the theory. And like I said, I'm sort of the making a cocktail type. I mean, in work, outside work, I'm more like drinking the cocktail. But so this talk is also going to be mostly about the making the cocktail part. Although now and then I will mention, of course, some tests that are being done. But I'm sure, and maybe I've already had some speakers here that are more on the experimental side. There are some colleagues that can give you very exciting lectures about that. So, so let's see. There's like with a cocktail, there are some ingredients that you want to put together in physics. Now, in a cocktail, it's very tangible ingredients like, you know, this a little bit of gin and a little bit of vodka and maybe a little berry. In physics, we actually have sort of two types of ingredients. One are rather tangible, and the other ones are the conceptual ingredients. So let me start with the conceptual ingredients that go into our way of thinking. And I will list three. This is one of them. I will spend really some time, I just gave some headlines, but explaining them. But it's really these three that I'm going to mention that is sort of the starting point of any physicist thinking about a fundamental question. So the first conceptual ingredient is space and time. If you just want to say it in ordinary day life, it's where and when. You all know you have sometimes an appointment here tonight, and that's 8 o'clock. That's when, and that's here at number 89, and that's where. That's of course our perception of space and time. For us, it looks really like the time seems the same for everybody, and thanks to that, our appointments actually fit. That you both show up at 8 o'clock. Space also, and that's really the, say it in an expensive way, the Newtonian way of thinking about space and time. Like time is the same for everybody, and space is something absolute. Like it starts here, and you can just go on forever. But as you probably have heard, Einstein had some revolutionary thought, and I'll just give you the final result. It is a consequence of the fact that the speed of light is finite, but it's not so important. More the consequence of it is that space and time are not so absolute. Time is really dependent on what you do, in particular how fast you move. Like if you go faster, your clock actually goes slower. I mean, it's an actual. He predicted it, and it's an actual fact. And likewise, space. It also the way space looks really depends on what you are doing. So that was a big revolution. And last but not least, Einstein discovered that the very space-time, so space and time together, that we live in. So I hope, maybe I should emphasize again, to us they seem kind of separate, space and time, but you can really view them as one package.